My name is Yanxin Liu. Today, I'm going to introduce our research, which is the multi-objective coordinated development path for China's steel industry chain based on water energy economy nexus. We all know that steel industry is very important because it could help a country to improve their economy, especially for China. But it also needs a lot of water and energy. From this figure, we could see that there is a huge imbalance among water consumption, energy consumption, and economic benefits in steel industry. In addition, there are a large number of steel products like the upstream, including iron pellet, to the downstream like cast iron steel rolling to the steel scrap. And these steel products are shown like a chain. Therefore, to analyze the sustainability of steel industry, it's necessary to evaluate the relationship among water, energy, and economy from the perspective of steel industry chain. There are 3 points about our innovation. The first one is that we propose an optimization model, and the dependency relationship is analyzed from the perspective of industry chain. The second part is that we identify the key steps and the key products of the industry chain. And the last point about the innovation is we found a multi-objective coordinated development path of water energy economy in steel industry chain. About methods, before we build a model, we need to quantify the water, energy, and economy relationship. So we combine the random forest and Gene3, these 2 algorithms to measure the relationship, and figure 2 shows the flowchart. Then we could build a model, and the table 1 shows the multi-objective functions among this model. And these functions include the minimum total water consumption, minimum total energy consumption, maximum total economic performance, and maximum water, energy, and economy relationship. About this model, we use the QPSO algorithm. In this model, we also set some parameters, and table 2 shows the definition of these parameters, and the specific meaning are listed here. And table 3 is the constraint condition. And these conditions include the water resource, energy resource, and the economic development and the yield constraint of these steel products. All of these constraints are coming from the Chinese government documents and the official policy goals. To predict the development of Chinese steel industry chain, we also set some scenarios. Table 4 is the baseline scenario, which is only focused on water or energy or economy in each dimension. And table 5 and table 6 are the 2 series of scenarios, which are focusing on the improving resource utilization rate and the advancing production technology. And in these 2 kinds of scenario, we added the steel products, which are shown as the right column. And these products we chose also according to their production process and some technology of the current situation. About results, there are 2 parts about it. The first one is the current situation. Figure 4 shows the current development of water, energy, and economy in Chinese steel industry chain. We could see that the energy dimension shows the most significant change, and it increases most, like the yellow line shown. It increases a lot, especially from the 2016 to 2019. And the variation of water resource dimension, the red line shows that it fluctuates very slightly. And the economy dimension, the green line shows it greatly fluctuates. We could see it falling down firstly, then gradually rising up. Figure 5 shows the water, energy, and the economy relationship in Chinese steel industry chain. And from figure 5a, we could see the relationship of water and economy has changed from one-way dependence to two-way dependence. And from figure 5b, we could see the dependence of economy on energy is always higher than the energy on economy, which is the orange line. The value of it is always higher than the other line. And the relationship of water and energy, the relationship is in a state of coincidence. We could see it from figure 5c. And the last figure shows the relationship between water, energy, and economy is very weak at the present. But from this figure, we could also see the value of these lines are going up, which means the sustainability of Chinese steel industry chain is going well. The second part is the simulated results. And figure 6 shows the total water consumption in these scenarios. And we could see that the decrease of water consumption in scenario 9, which is this orange line, is the most significant from 2019 to 2030. And this result indicate that controlling sinter and shear rolling steel may help people reduce the total water consumption in China. And about energy consumption, this figure shows that the decrease of energy consumption in S4 and S5 are the most significant, which two lines, the green symbol and the blue star. And the decrease of energy consumption in scenario 5 is the most significant, which is this blue line. Figure 8 shows the total economic value in these 12 scenarios, and we could see the gross economic value in S7, S8, S9, and S11 is higher than the baseline scenario, which means that these 4 scenarios is really good for the Chinese economy. About figure 9, we also predict the relationship among water, energy, and economy in these scenarios. And we found that the S8, which is this orange line with purple symbol, this line, the value of this line is always higher than the other lines. And it means that from the perspective of sustainability, scenario 8 is really good. Therefore, we analyze the yield of the steel products in this scenario 8, and we found that the yield of scrap steel, which is green star, this line, and the recycled steel, which is a red bow line, this has increased very significantly. And we also found that the production of sinter and shear rolling steel, they decrease very significantly. Except this, the value of iron ore in this scenario is going really high. We could see that this purple line is not good for the sustainability because mining it will damage the environment. Therefore, maybe in the future, people need to focus on the controlling the mining iron ore. According to our results, we also propose some policy implications. And the first perspective is about the industry chain. And we believe that in the future, we need to strengthen the recycling step and improving the reuse steel industry chain. And we also need to focus on the substitution effect, especially among some products. The sustainability effect can be fully utilized to actively promote the adjustment of industry structure. The second part is for steel products. And from the perspective of improving resource utilization rate, more attention should be paid to upstream products and downstream products. And from the perspective of production technology improvement, the midstream and downstream steel products should be given priority. That's all about our research. Thank you for your watching. Have a nice day.